Hello, Integrated Math 1. Welcome to Module 2, Topic 2, Lesson 2, Day 2. Hey! So we're on 2.2.2b. Yeah, we're doing the second day. So we're picking up where we left off last time. Last time, we talked about literal equations, and we said literal equations were equations where the variables represent actual measurements, right? That it wasn't just x and y for the sake of x and y, that if it says something like r, that's the radius. If it says something like h, that's the height, that our variables actually mean something. They're an actual measurement in the real world. And those, of course, were our literal equations. And we started playing with them last time. We're going to play with them a whole bunch more today. So the deal is that today we're really going to focus on taking those literal equations and solving them for a given variable, solving for a particular variable. And you'll see what I mean as we go. So we're on page M2-116 in our workbooks. And we have a box situation here, people. We got a box situation. So think inside the box is manufacturing new boxes for you pack 'em, we ship 'em, which they've decided to abbreviate as YIPSWE. I'm not even sure. But the you pack 'em, we ship 'em told think outside the box that the boxes must have a specific volume, all right? This is the most that we can pack into these poor boxes, probably because people gotta, carry them and ship them. And they do need to have a specific area for the base. So the base had to be a very specific area, which again makes sense because if people have to pick them up, carry them around, you can't have anything too big. It makes it hard to deliver, right? So the problem is this, that you pack them, we ship them did not specify a height for the boxes. They said, look, it can only hold this much. That's how big the volume can be. And this is as big as our area of our base can be. But we don't care how tall the box is. It should be fine. So here's what we're going to do. We're going to start by writing the literal equation to calculate the volume of a box. Do you remember how to calculate the volume of a box? Once you've written that down, what I would then like you to do is to convert this formula to solve for the height of the box. So first things first, you may need to look it up. That's okay. What is the formula for the volume of a box? What's that literal equation? Write that down first. And then once you've written it down, see if you can manipulate, use your properties of equality, all that good stuff, to try to get the h all alone. Try to get the height all alone. Go ahead and hit pause, see what you can do with this. And then, of course, once you hit play, you can check your work. All right, are you ready? Are you ready? Are you ready? Oh, I'm not ready. My pen's not there. Oh my goodness, where is my pen? Down here. There it is. Now I'm ready. So write a literal equation to calculate the volume of a box. Do you remember the formula for the volume of the box? Do you remember you can find the volume of a box by doing length times width times height? It's also possible, you could also say that volume is the area of your base times the height. That's also an option. You could have written that down as well. I'm going to stick with these guys. Volume equals length times width times height. Again, here, hang on. I'm making a mess of things already. So yay, we wrote down the formula for the volume of a box, our literal equation. We're used to calling them formulas, but now we know they're literal equations. But I want to get the h totally alone. Well, the h is being multiplied by L and W, and we undo multiplication with division. So I'm going to divide by LW, by my length times width. But if you do it to one side, you must do it to the other. You know how this works. And of course, those L's will cancel out. The W's will cancel out. Oh, look at this. It works. So look at that. So we've got h equals, so the h is all alone, my volume divided by my length times width. Of course, you know the area is length times width as well. So I suppose it's also possible you could write your formula as h equals volume divided by the area. Also a possibility. The area of your base. Beautiful. Nice work. Let's see what we can do with it though. So now that we have this lovely formula, which is a great formula, You pack them, we ship them, specified that the volume of the box must be 450 cubic inches. They said, look, this is the most that we can pack into our boxes. And the area of the base, so the area of the bottom, that length times width, must be 75 square inches. So you just solved that volume formula for your height, didn't you? So use that formula that you just came up with on that last problem, plug in your volume, plug in the area of your base, and then determine the height of the new box. You might want a calculator handy. Go ahead and hit pause, see what you can do with this, and then hit play when you're ready to check your work. So let's see what we've got here. So we said the volume is 450 cubic inches. We said the area was the same as length times width, and that is 75 square inches. So here we go. That means that I can just plug in for V. Instead of V, let's plug in our 450 cubic inches. Instead of LW, that's our area, instead of length times width, our area, let's plug in the area of the base, which is 75 square inches. So I'm going to plug it in, and I'm going to plug it in. And at this point, I need a calculator. Hi, Mr. Calculator. So 450 divided by 75. Oh, I got 6. Oh, and inches cubed divided by inches squared gives me plain inches. So it looks like the height of the box can only be 6 inches. It's not a very tall box. Nice big base, not a very tall box, I suppose. That's all right. I wonder what they're shipping. Just curious. Oh, I guess you pack them, we ship them. You get to decide what goes in the box. That's fair enough. Excellent. Let's move on to something more sweet, shall we? The volume of an ice cream cone is the measure of how much ice cream fits inside the cone, right? I mean, that's how you find volume. It's how much you can fit inside. So the volume of an ice cream cone is the measure of how much ice cream fits inside of the cone. An ice cream cone company wants to make an ice cream cone with a greater height that still holds the same amount of ice cream. So they have this ice cream cone. They want it to be taller, but they want to keep the volume the same. So let's do just like we did last time. First things first, you need to write an equation to calculate the volume of a cone. So what's the formula for the volume of a cone? Start with that. And then just like last time, solve for H. Get the H all alone, okay? Go ahead and hit pause. There may be some hints to help you off to the side. Go ahead and hit pause to work that out, and then hit play when you're ready to check your work. So, well, I expected that you probably were going to remember the volume for a box, length times width times height. I didn't really expect that you were going to have the volume of a cone memorized. So they did give you a little hint off to the side. Now, I don't like the way they wrote that formula. This is how I usually write the formula. I usually write it as volume equals 1/3 pi r squared times the height. It's a little less scary looking than this guy over here. I mean, it's still a little scary looking, but it's a little less scary looking, I guess. Something like that. And we need to get the H all alone. All right, first problem. I don't like that 1/3. I do not like the 1/3. But we can undo a fraction by multiplying by the reciprocal. The reciprocal of 1/3 is 3/1, or 3. So I'm going to start by multiplying both sides by 3. It just makes things easier. It means the 3 and the 1/3 will cancel out. It just makes things nicer. So I have 3v equals pi r squared h. I need to get the h all alone on his own, and he's getting multiplied by this pi r squared guy. So I'm going to go ahead and divide both sides by pi r squared. So the pi's over here will cancel out. The r squareds over here will cancel out. Oh, yay! So we have h equals 3 times the volume over pi times the radius squared. Yay! Nice job, us. We did good. Hey, look at us and our mad skills. Mad skills, we have them. That's beautiful. It felt a little weirder because of the fraction, but really we just multiplied by its reciprocal, and once it went away, this was no problem. Now we're going to use this equation. Are you ready? Are you ready? We're going to use this lovely equation that we just came up with to talk about a few things. First of all, let's talk about the units, shall we? So here's our equation, h equals 3 times v over pi r squared. Can we talk about this for a second? How do the measurements work out on this? How do the units work out on this? Okay, can we give this some thought? I know that volume is measured in cubic units, right? So this would be units cubed on top. But check out the bottom. Isn't this the area of a circle, right? Pi r squared, right? Area of a circle equals pi r squared. That's how you find the area of a circle. And area is measured in units squared, right? Okay. So the area of the base of the cone is in square units, since, the radius is multiplied by itself, units times units. But if I do units cubed divided by units squared, I get plain old units. Gives me a linear measurement, which gives me the height. So if I take my volume in units cubed and I divide by the area in units squared or square units, then that gives me plain units for my height, right? These guys just gives me plain units. Yay! So that gives me a nice linear measurement for my height. So my units are working out okay here. That's good to know. Now, we are still using this formula. Are you ready? You know what's coming up next. There's more. We're not still using the formula. My bad. We're done with our ice cream cones. It's a shame. I like ice cream cones. Let's move on to trapezoids. Formula for the area of a trapezoid. Do you remember what trapezoids look like? Do you remember how they have a single set of parallel sides? And then they do kind of this thing here, right? It's been a while. We got trapezoids. So the area of a trapezoid is 1/2 the height. And remember, height needs to be perpendicular to your base. And be like height. 1/2 height times the sum of your two bases. So if you're like, this is base 1, this is base 2. So the area of a trapezoid is 1/2 the height times the sum of the two bases, which we'll call b sub 1 and b sub 2. So h is its height, b sub 1 and b sub 2 are the lengths of each of the bases, those two parallel sides. Here's what I would like you to do. I would like you to take this lovely formula, because heaven knows I did not expect you to have the area formula for a trapezoid memorized. I would like you to take this lovely formula and, just like we've done with the other two problems, solve for the height. Solve for h. Get h all alone. This one's a little trickier, but I think you can manage it. Go ahead and hit pause to see what you can do with this, and then hit play when you're ready to check your work. All right, guys, how you doing? How you doing? So I took my formula. I hate the 1/2. I hate the fraction. So I'm going to get rid of my 1/2 by multiplying by its reciprocal. The reciprocal of 1/2 is 2. So I'm going to multiply both sides by 2. So the beautiful thing about that is, of course, the 2 and the 1/2 cancel each other out. That's why we did it. So we get 2a equals h times b sub 1 plus b sub 2. Normally I would distribute the h, but the truth is, I don't want to do that. I want the h to be alone. I don't want to spread out the h. I want to get it alone. I want to get rid of this. Now watch carefully. Parentheses means multiplication. You know this. So here's what we're going to do. We're going to divide. Since it's being multiplied, we're going to undo with division. So we're going to divide the sum of b sub 1 and b sub 2. But you also know the division property of equality says if you do it to one side, you must do it to the other. Aha! So as weird as this looks, because you have the same thing on top and on bottom, it cancels these guys out. It does. And so you find out that h is all alone now, so the height equals twice the area divided by the sum of our bases. because you know it's all about that base. I know you thought it. All right, now that we have our lovely formula, and it is a lovely formula, let's take this a step further. Let's use our formula to determine the height of a trapezoid with an area of 24 cubic centimeters and base lengths of 9 and 7. Go ahead and hit pause, plug everybody into your new formula, and then hit play when you're ready to check your work. All right, here's my formula. I'm going to plug in. I know that the area A is 24. I know that one of my bases is 9, and I know the other base is 7. So I'm going to plug everybody in. And at this point, I need to clean up. Please remember to take care of the top guy and take care of the bottom guy. Dividing should be the last thing you do. I think most of you are pretty good about that. So 2 times 24 is 48, and 9 plus 7 is 16. So now I have 48 over 16, and of course, use a calculator if you need to, that's fine. 48 divided by 16 gives me 3. So it looks like my height, centimeters, right? Cubic centimeters, centimeters. My height is 3 centimeters. Don't forget your units. Those are important. Don't forget your units. Alrighty then. This isn't too bad, right? I mean, we get a variable alone and then we plug our stuff in. We can manage this. We can manage this. Let's take it next level though. Here is a literal equation. Z equals A over B plus C over D. It's okay if you aren't familiar with this equation. I didn't expect you to be. But I would like you to solve for each variable given. Notice you don't have to solve for every variable. For part A, you need to solve for variable A. And for part B, you need to solve for variable D as in dog. So watch out for that. So go ahead, hit play when you're ready. Hit pause to work these out. Notice you need to justify your solution method. Tell me your properties that you're using. Go ahead and hit play when you're ready to, I can say this, hit pause to work these out and then hit play when you're ready to check your work. All right, guys, let's do this. So I've got Z equals A over B plus C over D. All right, I want to get A all alone. And actually, I'm going to use the box method here. Oh, that's a bad box method. I'm going to get rid of that CD first because it's the first step to get A alone. So that means I need to subtract C over D. And if you do it to one side, you must do it to the other. Oh, by the way, it did say to justify, so I'm going to make a note here. Subtraction property of equality. Yeah, we're coming back to it. Always got to get that practice in, right? So this means I have Z minus C over D equals A over B. All right, that's pretty good. That's pretty good. But of course, I need to get A all alone, and right now it's being divided by B. Well, you know how to undo division. You undo division with multiplication. So I'm going to go ahead and multiply both sides by B. Which makes that the multiplication property of equality. Sorry, my pen went weird. It happens a lot around here. This is great because this means the B's cancel out and we just have A, which is good. That's what we wanted. But check out what's going on over here. I think another property needs to happen here. I believe we need to distribute that B. That's right. Distribution property is back in full force. So distribution property, not of equality. It's just a plain distribution property, nothing fancy there. So we'll distribute this. B times Z is, well, BZ. Minus B times C over D. Well, remember you just multiply with the top here, right? And divide out the bottom. So B times C, so we'll put BC over D, divide out that D. Look, we got our formula. A equals BZ minus BC over D. Hooray! Well, that was fun. Actually, that wasn't too terrible. As scary as it looked at first because of all the fractions, that actually wasn't really all that bad. I don't think D will be as kind to us. Oh, so for this one, we need to solve for D. Okay, and we have to justify, so we got to make sure we do all the things. So Z equals A over B plus C over D. I'm going to make my big line. All right, D is over here, so I want to get rid of this guy first, don't I? So since it's positive, it's being added, I'm going to subtract A over B. And if you do it to one side, you must do it to the other. Oh, which means this is the subtraction property of equality. Beautiful. So over here, I get Z minus A over B. I do like to put little notches in my Z's, by the way, in case you didn't notice, because sometimes otherwise I'll accidentally think my Z is a 2, and I don't want that to happen. So I'm going to put a little notch in there. It'll make it better. These cancel out, which of course is why we did it. And then we have C over D. Now, this is where you may have started to have some problems because you were like, how do I get D alone? It's on the bottom. Arg. So these next steps may look a little weird to you, but just roll with it, okay? How about if I get the B off of the bottom first? Because we just don't like fractions, right? I mean, if we can avoid them, we're going to avoid them. So I'm going to go ahead and multiply both sides by B. Ooh, which by the way, makes that the multiplication property of equality, which I'm going to abbreviate. Unfortunately, nothing cancels out over here because we just get BC over D, which is funky, but we'll take it. Over here, we do need to distribute. Oh, you know I'm about to have to write distributive property. Yes. So distributive property. So B times Z is, of course, BZ. Now, here's the thing, though. When I do B times, oh, that's a minus sign. When I do B times A over B, the B's cancel out, and I just have A. So actually, that does look better, but it feels weird because I still don't have my D all alone. Can we get D off of the bottom? I don't want to divide by D. How do you want to do division? Multiplication. So let's multiply everybody by D. So I'm going to multiply, which means multiplication, property of equality. Here we go. So these D's cancel out, which is why we did it. We've got a BC over here. Now, normally I would distribute, but remember we're trying to get D alone. I don't want to spread D out. I want to keep D like by himself. So I am not going to use distributive property because I want to get D alone. I don't want to spread it out. And you know what? This now looks like the issue we had with the trapezoid thing, right? Oh my gosh, D times BZ minus A, which means I can undo the multiplication by dividing. And if you do it to one side, you must do it to the other. So those will cancel out. Ooh, which means we're using the division property of equality. So it looks like we got D alone. So D equals BC over BZ minus A. Ugh, that one was mean. That one was mean. But we got there, so good for us. Hooray. Oh my goodness. Oh my goodness. Oh my goodness. All right. Let's come back to some more familiar and less stressful formulas. All right. Let's go over to the talk on page 118. So the formula for the volume of a cylinder is V equals 2 pi r h. So V is the volume, R is the length of the radius, and of course H is the height. So the first thing I would like you to do for number 1 is, can you take this lovely formula just like we did with all those other problems, and can you solve for the height? Can you get the H all alone? Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. All right, so here's my formula. V equals 2 pi r h. I want to get the h alone, but it's being multiplied by these jokers. Well, you undo multiplication with division. So let's divide by 2 pi r h, but if you do it to one side, you must do it to the other. Division property of equality and all that. So over here, I can see that the 2's cancel out, the pi's cancel out, the r's cancel out, and h is alone. So h equals V over 2 pi r. So the height of the cylinder is equal to its volume divided by 2 pi times the radius. Yay! Okay, so now that you have this lovely formula, you got the h all alone, let's do something with it. The volume of a can of soup is 37.68 cubic inches, and the length of the radius on the base of the can is 1.5 inches. So use the formula to determine the height of the can of soup. And don't forget, for pi, you can plug in 3.14. I know you know that, but don't forget it, okay? Go ahead and hit pause to use your formula and work this out, and then hit play when you're ready to check your work. All right, so I'm using the formula. This is the formula we left off with, right? Height equals volume divided by 2 pi times the radius. All right, let's plug in what we know. We know what the volume is. It's 37.68. So I'm going to plug that in. 2, I know 2. Ooh, and we know what pi is. Pi is 3.14. So I'm going to plug in for pi, 3.14. And I'm going to plug in for the radius, which they said was 1.5. And heaven help me, I am grabbing a calculator because, oh my gosh, like I know what that step is. Let's take care of that denominator first. So if I do 2 times 3.14 times 1.5, I get, on the bottom, I get 9.42. So I just multiplied these three guys together on my calculator. And that means I still have 37.68 on top. So fine, last step. Let's do it. 37.68, and we will divide by 9.42. It's what I have my calculator for. And I get an answer of 4. For what? For what? We need units. Oh, this stuff is measured in inches. Check that mess out. So it's 4 inches. Bam! So the height of our soup can is 4 inches. Good job, us. Is that 1 serving or 2? And is it concentrated? Like you have to add water to it? Or can you just like pop that sucker open, warm it up, and eat it? I'm just curious. I don't know what kind of soup it is. Condensed soup, proper soup, I don't know. Let's talk about the surface area of that cylinder though. So we figured out how much we could fit inside of our cylinder, but what if I wanted to wrap the cylinder? What if I wanted to know how much material it takes to make the cylinder? I need my surface area, right? So here's the deal. Formula for surface area is SA equals 2 pi r squared plus 2 pi r h. Now, of course, SA is the surface area, R is the length of the radius of the base, and H is, of course, the height of our cylinder. So you know what's coming up. I want you to convert this formula to solve for the height. Get the H all alone. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. You ready to do this? You ready to do this? All right, let's grab our formula. So I only see the H over here. So let's get rid of this guy first, shall we? Oh, I'm going to make a big old line. I'm going to make my big old line. Let's get rid of this stuff over here. And it is being added, so I'm going to subtract 2 pi r squared. But if you do it to one side, you must do it to the other. That's what the addition property of equality says. So those cancel out. So over here I have my surface area minus 2 pi times the radius squared. Equals, ooh, bring this stuff down, 2 pi times the radius times the height. I need to get my height all alone on his own. He is not all alone on his own right now. So I'm going to go ahead and divide, since these are being multiplied, I'm going to divide the 2, the pi, and the r. But if you do it to one side, you must do it to the other. So I am. All right, what do we got here? The 2's cancel out, the pi's cancel out, the r's cancel out. That's why we did it. And it looks like we get H equals my surface area minus 2 times pi times the radius squared divided by 2 times pi times the radius. Now I'm going to warn you right here, right now. The 2's do not cancel out, the pi's do not cancel out, and the r's do not cancel out, because you have to take care of that subtraction before you can divide anything. So we're kind of stuck with it like this. It's not the prettiest thing, but I mean, it does the job. It's fine, sort of. We got the H alone. That's what we wanted, right? That's a good thing. So let's actually use it now. So now that we have our lovely formula, let's use it. The surface area of a can of soup is 51.81 square inches. The length of the radius of that base is still 1.5 inches. That has not changed. So I would like you to use that formula to determine the height of our can of soup. And don't forget to use 3.14 for H. Go ahead and hit pause, plug in all your stuff, grab a calculator, work it out, and then hit play when you're ready to check your work. So here's our formula. It's a lovely formula, and we're just going to plug everybody in. I know what the surface area is. It's 51.81, so I'm going to plug that in. I know that pi is 3.14. I'll plug that in. I know the radius is 1.5, so instead of r squared, that's going to become 1.5 squared, over 2 times pi, which I'll plug in 3.14, times the radius, which means I'll plug in 1.5. So this is what we get when we plug everybody in, and we are plugging in everything. There's a lot of cleanup we need to do. So I'm going to grab a calculator. I'll worry about this 51.81 in a minute. Don't forget that you're supposed to multiply before you subtract. And actually, you have to do your powers first. So let's take care of our powers here. 1.5 squared, 2.25. So 1.5 squared is 2.25 times 3.14 times 2. So here's what I got. I'm going to grab my pen here. Here's what I got. I still have 51.81 at the top. Minus, I squared this and then multiplied, and I got 14.13. Let's clean up the bottom as well, though, since we're here. 2 times 3.14 times 1.5. And I got 9.42. We should take care of the subtraction before we divide, because the division bar kind of creates a group up top. Let's take care of our group up top. 51.81 minus 14.13 gives us 37.68. And so our final step will be to divide that by 9.42. So divided by 9.42, I get 4. Again. 4 what, by the way? Oh, look at our units here. There we go. 4 inches. Hey. So it looks like the height of our can is still 4 inches. Do you get the feeling we just did a whole new problem for the exact same can? possible. It's possible. All right, guys, as always, I hope you found this helpful and I hope you found this useful. If you've got questions or concerns, please let me know. You can email me, but even better, ask me questions. Ask me questions during class. Ask me questions at the end of class. Come in and see me during office hours and ask questions. Come get help. And again, hope this was useful. Hope this was helpful, and I'll see you soon. Bye.